Okay, so we are ready today to begin our Geode inquiry activity. And remember that to inquire means to wonder and then discover. So I know it's a little small, but it's on your doc too. Our I wonder question is this today. Can the physical characteristics of a geode be used to predict its internal structure? It's almost like saying, can we collect data about the outside of the geode to predict what it's like inside? So let's take just a second though to discuss what a geode even is. So if you check out these with me, okay, you can see what a geode looks like. Now on the outside, it would just look kind of like a boring rock. But a geode tends to be hollow inside and has beautiful crystal formation. So what we have today are two geodes from my tub of geodes. And in the past, students have actually done all this data collecting themselves, but I'm going to help you with that through the video. And then you're going to be predicting which one will be the most hollow inside. And then you'll see them be cracked open to see if you were right. We're also hopeful that you'll be able to take a geode home so you can open one up yourself. So let's start with the data table. The first thing that you're going to do is color. So if you study this, I know it might be a little difficult to see. This is Geode 1, and it actually has some reddish brown in it. So there are parts of it that are tan, but parts that are definitely reddish brown. And then this is Geode 2. So you're going to be writing or typing that in. This is Geode 2 here. Geode 2 is also tan, but it has some hints of pink. So let's review those colors, right? Geode 1, tan with hints of reddish brown. And Geode 2 is tan, but it has a little bit of pink in it. Okay, now our next one is texture. And so in your mind, think about what texture means. So texture means the way that they feel. And so if you look with me, when I feel these, they honestly feel very much the same. So I don't think there's a big difference here. Here's what I think you should either write or type. They feel gritty. Right? I can feel little bits of something chunking off in there. It feels gritty and rough in texture. Okay, now we get to things that we're going to need to measure. So the first thing there is the biggest circumference. And in math, you might remember that circumference means the distance around. And so I'm going to take Geode 1, and of course we're going to go in centimeters instead of inches because of metric. And you notice that Geode 1 has this little sticky out point, so that would be its biggest circumference. Okay, so get ready to write or type. Okay, so we are on exactly 13 centimeters. So Geode 1 circumference is 13 centimeters. Geode 2, okay, get ready, there's a difference here. Geode 2 circumference is smaller, 11.5. So again, we have a circumference of Geode 1 at 13 centimeters, Geode 2 at 11.5. Okay, next up we're going to find the mass of the geodes. And when we say mass, that's really a, how should I say it? Mass is a quantification, is a piece of data, an observation about how much matter is in an object, how much stuff. So if there's more stuff, then you'll have a greater mass. And we're going to use a triple beam balance to figure that out. So let me show you down here. This is a little tough to do. Okay, so this is a triple beam balance, and you'll notice that I'm getting, it's triple beams because there are 3 beams. We start with them all in 0. Now when I put my Geode 1 on there, immediately you notice that the hand goes down that it's sitting on. So now we start moving the beams to find its mass. You always start with the hundreds place, and you get it in the little notch there, and you ask yourself more or less than 100. Well, it's definitely less than 100 the way that this bar went down. So now I go back and I start moving the tens place. So 10, excuse me, so 10, nope, it's more than 10, more than 20, more than 30, more than 40, more than 50, more than 60, but less than 70. So now I go back to the 60 and I start moving the ones. And I'm looking for this to balance perfectly. This takes a little patience. Oh, the suspense. Okay, we're going to call that good. So here's what we write for the mass. 60, and then it's only 0.8. Okay, so you're going to put 60.8 for Geode 1's mass. 60.8. Okay, next up, we're going to find the mass of Geode number 2. So same procedure. More or less than 100, definitely less than 100 grams. More or less than 10, more than 20, more than 30, more than 40, less than 50. So I go back to the 40s place, and now I start moving the ones. Oh. All right, so we have 43.6. Here it is again for Geode 1, a mass of 43.6. Okay, now our next step is to find the volume. And so mass is the amount of stuff in an object measured in grams, while volume is the amount of space that the geode takes up. And so for this, I'm going to be using a method called water displacement. And so it's very much like when you get in a bathtub or into a swimming pool, the water level goes up based on the amount of space you take. Let me say that again. When you get into a body of water, the water level rises based on your space that you're taking up, based on your volume. So we're going to use that same method here. Now I know it's difficult for you to tell, but I've started with the water level at exactly 200 milliliters. And so I'm going to drop the geode in and be careful to cover the top. Let me show you the top there. Okay, ready, set, go. I tried to reduce splashing by covering it. I lost just a little bit. Okay, now this graduated cylinder goes up by 5s. 5, 10, 15, 20. Okay, so now I'm at 225 milliliters. Finish my thought in your mind. I started at 200 milliliters. So that means the volume is 25 milliliters. So you're going to put 25 milliliters in your chart where it says volume. Okay, now to do the other one. So I need to dump my geode out. And then I'm going to fill it again, right to 200 milliliters. And honestly, it wouldn't matter where I started, just so I knew where I started, and I was only counting the amount of milliliters that the geode went up. Okay, so I need a little more to get it to 200. Okay, we're right on it now. So I'm going to use water displacement again. Geode 2 going in. And now that only went up 3 little lines. So this graduated cylinder goes up by 5. So 5, 10, 15. So you have 15 milliliters for the volume. Okay, now the final thing I'm going to leave up to you. So on this chart, you can see the final thing is density. Density is actually a measure of how tightly packed the mass is. So high density geodes would have tightly packed mass. Low density geodes, it would be spread out. So to figure that out, you're going to take your mass, and you would have a calculator run your computer, mass divided by volume. So go ahead and do that. Why don't you go to the nearest, I would go to hundredths place. So if it came out as like, let's say a density of 1.7254, then you'd go to 1.73 because the 5 would make that go up. So go 2 decimals on your density. Now, after you're done with that, you're going to be following the rest of the activity. You're going to be making an inference about which one is most hollow. Once you've done that, we're going to have a special guest, I hope. I need to talk to him about it, to crack these geodes in front of you. Okay, so again, figure out that density, then predict which one will be most hollow.